Predict the elimination product formed by the solvolysis of 2-bromo-3-methylpentane with ethanol. All right, so here we're going to focus on elimination. It's telling us to do that. Solvolysis is telling us that it's going to be more like an E1 mechanism. Okay, that's what solvolysis is. And 2-bromo-3-methylpentane is, of course, going to be our substrate. And then we also have ethanol, and that's going to be our nucleophile. Okay, because even if we are doing solvolysis, what is our solvent? And the solvent here is ethanol. All right, so let's get started. So we have 2-bromo-3-methylpentane. So let's draw the structure out. And so we have 2-bromo-3-methylpentane. And so since we're doing an E1 reaction, the first step we have to do is get rid of the bromide. And so there is my leaving group, and of course we form the carbocation, okay, over here. So when you have a carbocation mechanism in anything that you do, whether it's substitution or elimination, E1 or SN1, it doesn't really matter. But you have to see, can I do rearrangement? Okay, so that's one of the most important things when you think about carbocations. All right, it's just when you form a carbocation, see, can you rearrange it to form a more stable carbocation? All right, so when you form a more stable carbocation, what are you going to do? You're going to have to shift some things. So what are you going to shift? You can shift a hydrogen, you can shift a methyl group, you can shift a phenyl group. Okay, that's about all you can do. And remember, if you have a tertiary carbocation, you don't have to shift anything. All right, so we are all set. But if you have a secondary carbocation, okay, then shift. All right, or if you have a primary carbocation, then you shift. All right, in order to form a more stable carbocation. A secondary will not shift to secondary. Okay, what's the point? All right, so a compound doesn't have so much work to do. So in any case, let's look at this compound over here, and let's look at this hydrogen and this methyl group here. We also have hydrogens on this carbon, but the one on the right hand side, that's going to be a primary carbon. So obviously the carbocation is not going to shift over here because really, primary carbocation not going to form. Okay, so we're already at a secondary. So the only place we can shift it is to the left side. Now, if you shift it to the left side, there are two possibilities. Okay, you can do an H shift, or you can do a methyl shift. All right, so if you do an H shift, okay, if you do a hydrogen shift, it means that you're taking the hydrogen and you're moving it to where the carbocation is, which means that your methyl group is still over here. The hydrogen has shifted, so which means hydrogen is here now, so which means that this carbon now gets the carbocation because the hydrogen has shifted. So that means you form the carbocation on this carbon, okay, right here. Now if you do a methyl shift, so a methyl shift shifts over here, then in that case your hydrogen is still over here, the methyl has shifted here, the carbocation is now here, okay, because once the methyl moved, it created a vacancy. So what happened? Let's look at our carbocations. In the first case, we formed a tertiary carbocation. In the second case, we formed a secondary one. So obviously, secondary to secondary is not going to form. Sometimes you have to write the shift out in order to see these things. If you're comfortable, then you don't have to do it. Okay, so I'm going to go ahead and take this shift over here. Let me just go ahead and write this again. Okay, so it's nice and clean. And so here is the methyl, here is the hydrogen, here is the carbocation, and I'm going to shift the hydrogen. So it's a H shift. It's always a good idea to write these things out so you can see what you've done eventually. And so here is the methyl group still here. I will not write the hydrogen again because I've shown you already how it's shifted, so we don't have to do that. So here we have our carbocation. So now we have to do elimination, okay, because that's what the problem told us to do. So when you have elimination, for elimination, E1 or E2, it doesn't matter. It has to be a 1-2 elimination, or as we say, an alpha beta elimination. So a 1-2, 1 is always where you have the carbocation or where you have the leaving group, and the same goes for alpha. That's where the carbocation is or the leaving group is, and 2 is where the hydrogen is going to be, or beta is where the hydrogen is. So here what we're going to have to do is we have to figure out where are my hydrogens, because I have a carbocation. So which means that I am looking at this carbon as my alpha, or 1. Okay, whichever you want to. If you like the alpha, you go for the alpha. All right, so then if that's my alpha carbon, or that's my carbon number 1, so where is my 2? My 2 is here, here, and here. Okay, so I have 3 carbons that are attached to the carbocation. Now, if you all agree with me, and I really hope you do, okay, for this one, is that these 2 carbons that I'm going to circle now, they are exactly the same, okay, because they are equivalent. They are attached to another methyl group, okay, on both sides, so they're equivalent, all right, which means that I need to worry only about 1 hydrogen over here. If I write the other hydrogen, it's going to be the same. Okay, so no need to write that one out again. All right, so only 1 hydrogen here. Now for the other carbon that I looked at, and here I have another hydrogen. I have 3, but 1 is enough, okay, to draw out, because we're going to have to show the mechanism, okay, of what we are doing. So now what we're going to do is we are going to do the elimination, and then we'll write the products, okay. So now this is where the ethanol comes in, because until now it was just the leaving group going away, forming the carbocation. We didn't really have to do anything with the solvent yet. Okay, now we do, because now the solvent is going to be kind of like the base, and it's going to pick up the proton. Okay, and the proton is going to leave with its electrons behind. Okay, over here. So now I get this product, okay, for the green hydrogen. Now let's go ahead and write for the purple one. So again, we have the C2H5OH. Now this one coming in here, picking up this proton, which is leaving its electrons over to the carbon. And now the product is going to be this. Okay, so we get 2 different kinds of products in here. So when the problem says write the products here, so that's fine now, because yeah, we are getting 2 products in this case. All right, so first let's go ahead and classify these products, and the green one, okay, is going to be the Zaitsev product. And the Zaitsev product, remember, is the more stable alkene. And the purple one is going to be the Hoffman product. Hoffman product is the less stable alkene. So which is going to be my major product? That's the important one, because in this case, the Zaitsev product, okay, is going to be the major product. That's the more stable alkene. So wherever you have a more stable alkene forming, that's going to be your major product. And that's something that happens with E1 all the time. So you have to be careful. Whenever you do E1, just try to see how many beta hydrogens do you have in order to get different products.